Hey everyone, and welcome to my talk today. I'm going to be sharing some lessons that we've learned from taking organizations to the cloud over the past few years. Just a quick introduction about myself. My name is Naude. I'm a senior cloud architect specializing in security and enterprise cloud architecture. My research interests include security, privacy and disinformation. I've been using AWS since 2013, and for those of you that are aware, that's even before AWS organizations were a thing. I have a number of AWS certifications which I'm looking at increasing over the next year, and I've been using Terraform since version 0.6, which is about 5 years ago. My Twitter handle is @JaredNaude. And I work for a company called Synthesis. We're based in South Africa. We're a specialized software development and cloud consulting firm for the financial services and retail industries. We're also an AWS Advanced Consulting partner with close to 200 AWS certifications. We're also a partner of HashiCorp, where we help our clients use and adopt HashiCorp products, including Terraform and Vault. In this presentation, I'm going to be sharing some of the lessons that we've learned as we've gone through this journey with various customers, and I'm going to use examples from Terraform and AWS. However, a lot of these lessons apply to other cloud vendors as well. So if we look at why people go to cloud, typically this is for cost reduction, agility, efficiency, and innovation, typically all leading to faster time to market. When organizations start on this journey, they will typically craft an organizational strategy that will talk about how they will use cloud and whether they will use hybrid or multi-cloud, etc. Once this is in place, they will typically get their mindset in place to see how they will use cloud, and then they'll start kicking off engineering work for specific POCs or capabilities that they want to build in cloud. Once that's been completed, they will then focus on operationalizing these capabilities that they have built. Once that's complete, they would then look at building the next set of capabilities or challenges or application migrations that they need to do. However, what we see is many organizations only see the end goal of being in cloud, but don't think about the journey that they need to take their organization through. So they see the big mountaintop that they want to be on, but they don't think of how they can get the rest of the organization there as well. It's important to understand that cloud is different. The operating model is different from on-premise environments. Organizations that take their legacy on-premise practices and techniques and bad habits into the cloud will not reap the full benefit of cloud. Application teams also have more freedom and responsibility in cloud, and this often will cause potential misconfigurations that can have very serious security issues. A really good example is the use of internet gateways. So in an on-premise environment, somebody can't just randomly go plug an internet connection into your network. That would typically go through some kind of change process. However, in AWS, it can take a few seconds for somebody to provision an internet connection into a virtual private cloud environment. And this is something that we need to think about when we look at the controls that we need to put in place. So the first lesson that I'm going to be talking about is understanding the cloud operating model. So as organizations kick off with a project, they put various foundations in place, and then what we typically see, due to an ineffective operating model, they typically stall after that. This typically happens when app teams are running in an environment before the environment is actually ready for them. So the cloud team often spends a lot of their time helping application teams rather than actually building the environment further. And in order to scale and grow, you need to have a proper operating model in place. And other things that can contribute to the lack of a good operating model is a lack of strategy and direction, a lack of a concrete roadmap, and no prioritization in place, typically from senior leadership. What we need to look at when we look at the target operating model is that as the various cloud projects will kick off, typically a cloud team will look after the platform and all of the shared network and security components, and the app teams will only look after the components that they need to look after. However, if the operating model is going to scale throughout the business, application teams need to take control over the platform as time progresses and as they increase their maturity in cloud. A cloud team will always be necessary to look after some of the more sensitive network and security components. And one of the things that we should always do is we should always strive for operational excellence. You can build the best golden horse for your organization, but if you can't run and operationalize it, it's not going to matter. So in order to achieve that, we need to look at how we do infrastructure provisioning. Unfortunately, many organizations use ticketing systems to provision infrastructure, which is often done manually. This leads to configuration drift between the various environments. And we can use infrastructure as code to enable this. So infrastructure as code is the practice of using code to describe infrastructure and services along with their respective configurations. This code is both human readable and machine consumable. We love using Terraform because it supports over 200 providers. Aside from AWS, some of our favorite providers that are supported is Vault, Cloudflare and Datadog, because we also partners with them. This allows a lot of flexibility when configuring multiple cloud providers, SaaS tools, as well as other infrastructure tooling. So as you adopt Terraform Cloud and Terraform Enterprise, all of the Terraform code is typically managed in a workspace. So we would need to talk about how we're going to manage all of these workspaces. So a workspace will typically contain Terraform code to create resources as specified along with their respective configurations. So how you manage your workspaces is actually quite important and will have a big impact in how you operationalize your cloud environment as you grow. In this example, we have a sandbox environment, 3 dev accounts, as well as 3 production accounts. And typically what we've done in the past is we would create workspaces, one workspace for the cloud team and one workspace for the application team. And this works really well because it's nice and granular, it's isolated to a specific account, change control is quite easy, and account-specific customizations are quite easy as well. However, the disadvantage of this is that there's a lot of repositories to manage because each of these workspaces will have their own independent repositories, and making the same change on multiple workspaces can be quite painful. And there's also a license cost when you scale. So if you have 100 accounts, effectively you would have 200 workspaces. An alternative to this is to create one workspace for the entire cloud team, which spans multiple environments, and then have the app teams managing their own workspaces. And this still allows the app config to be isolated to a specific account, and changes made to the guardrails are centralized. There are fewer workspaces and repositories to manage, and there may be a cost saving. On the disadvantages of this model, the workspace can actually be quite easy to manage. However, changes now become quite difficult because making one change could affect multiple accounts as well as multiple environments, which could raise the risk of each change that you make. And when you have a workspace that's that large, plans and applies can actually take quite a long time across multiple accounts. And it's very difficult to make account-specific customizations in this model. An iteration on this model is to actually split the centralized workspaces across different environments. So you're still reducing the number of workspaces that you need while still gaining some of the benefits of having some environments sharing some common components. So next we need to talk about misconfigured infrastructure. Security is one of the top concerns when organizations go to cloud, and services like Amazon S3, Elasticsearch, and databases often get a bad rep for being publicly exposed and misconfigured. If you read the news, you would have known about how many companies inadvertently expose their buckets to the internet without any access control. So one of the ways that we can actually address this is by using scaled learning. Scaled learning is the process of taking knowledge and sharing it throughout the rest of the organization. This knowledge would include how to go to cloud, what are the processes, what are the security policies, the links to resources, where to get help, as well as various architecture patterns, which we'll talk a little bit later on in this talk. And one of the ways that we can really unlock scaled learning in an organization is to componentize a lot of the infrastructure that we create. So Terraform modules can be created to describe these common architecture patterns and use cases, and these modules and configurations can then be approved by the organization. An example would be Amazon S3. So we might want to say that a bucket must not be publicly accessible. We want to restrict who can read and write the data, that all data must be encrypted at rest and by default, that all data must be owned by the bucket owner, that buckets must adhere to specific naming and tagging policies, and we can use Terraform modules to do this. We can also create modules for every single service that we plan to use, so that developers don't need to be an expert in that service to use that service securely. And modules can be combined in various ways to form higher order modules that can allow app teams to go to cloud faster. When we look at how these modules can be structured, there's a number of popular ways to structure this. So on the left-hand side, you will see a pattern used by a lot of modules in the Terraform registry, where there's a main file, an output file, and a variables file. In the middle, we have a pattern that we actually use at our company, where we actually split the files into the different services to make it easy to look for where a specific resource is. If you have over 200 resources in your in a specific module or repository, this allows you to go to specific resources very quickly without spending a lot of time trying to search for it. If you do combine multiple modules together, then the pattern on the right is actually a nice way to do that, where you actually group some of the capabilities together and then name the files after that. And in order to really achieve scale appropriately, you need to look at building higher order modules. So in this example, I have an application that uses S3, EC2. It has a RDS database. It has CloudWatch logs, as well as it makes use of a certificate manager as well, and it's exposed to the internet. So it has an application load balancer and WAF and analytics, plus some glue jobs. So all of this will be created as separate modules, but we can create a higher order module to tie all of this together and to make it easier for application teams to go and deploy their applications in the cloud. So as the organization adopts this methodology, we need to look at how we manage modules and source code. It's really important as you scale that the cloud team has their own project. There's a separate project for modules, and each app team gets their own project as well. This can reduce a lot of conflicts and permission issues that may arise. So the way that this would typically work is that the cloud team would have their own set of modules, which would contain the guardrails and other common infrastructure needed in the environment to support shared services, enterprise tooling, and other operational technology environments. And the cloud team would then enable the application team, as well as authoring some of the first modules that will go into the module repository. By having modules in its own project, it makes it easy to discover these modules without the mess of having potentially everybody's repository in that. And as this then scales, application teams can consume these modules created by the cloud team, but they should also be able to contribute their own modules back into the ecosystem. And this is one of the key things that organizations can do in order to grow and scale appropriately in cloud. Once these modules have been created, the next step is to create patterns, and these patterns would contain a brief overview of a certain construct. They'll describe who will use it and what challenges and decisions were made. They will talk about organizational policy, how logging and monitoring requirements are done, any costs involved, how it is implemented, and a link to the Terraform code, which would link to the module that was committed to the repository. If it's an operational technology service, typically there should be an architecture pattern which talks to how it's implemented in that environment, and then there should be a usage pattern which application teams can use to use the service in an easy way. When we start looking at architecture diagrams that should form part of these patterns, these architecture diagrams should be standardized in the organization. They should use standard iconography from the cloud provider that they use. So if they're using AWS, they should use the stenciling provided by AWS. However, one of the common challenges with architecture is the granularity to which it goes down. And one of the ways that you can address that concern is by using the C4 model, which was actually designed for software architecture, but can be retrofitted for infrastructure as well. So you can have a high-level overview of what a specific service or infrastructure does, and then you can break it down into its components as needed. So ideally, all decisions should be documented and stored in a central repository, which can either be on source control, Confluent, an internal wiki, or on SharePoint. I really like the fact that the UK government, for example, which is the example on the left, they actually have all of their decisions in source control, and the link is at the bottom of the slides if you would like to go look at it. And all of these patterns should then go to an architecture review board to be approved. So a few things to consider is that generally speaking, developers want to build applications and not manage infrastructure, and infrastructure people typically want to manage infrastructure and not have to worry about code. However, in the new way of working, the cloud poses a few problems to this model. A common challenge in the cloud journey is that developers are bad at creating and managing secure infrastructure, and for the lack of a better term, IT pros who come from the legacy on-prem world are used to managing things through portals and console and are not good at managing things through code. So a concerted effort needs to be made to do knowledge transfer between these groups, and scaled learning can be used to facilitate that. IT professionals should learn how to use Terraform along with best practices around version control, and when they do this, they can actually start contributing in a meaningful way to the organization. So the next lesson we're going to talk about is enabling self-service. Often there's a tension between the cloud team and application teams with regards to permissions and who does what. And often there's a dependency on the application teams to the cloud team. So we really need to look at how we can enable self-service in an organization. And as I mentioned at the beginning of this presentation, we really need to focus on how we build the cloud operating model. And often an ineffective operating model can have very serious consequences for growing and scaling the organization in cloud. And one of these things is around how you do change management. So a lot of organizations have a multi-step process that can often take 1 to 2 weeks to actually complete. And this will not scale well in cloud. So organizations that take their legacy workflows and processes to the cloud will not reap the full benefits of cloud. So in order to succeed in cloud, you need to change your operating model to adopt new techniques that can fill the compliance and regulatory requirements while enabling your team to deliver good software in a cloud environment. And one of the ways to do this is to not make large changes, but rather lots of small changes that are constantly being integrated into the environment. A good key performance indicator is to measure how often changes are made to production and how long these changes took to get there. And it should be a goal to try get the number of changes as high as possible while getting the time to production as low as possible. One of the common challenges that we see is around firewall rules. So firewall rules can easily be managed through Terraform, because most of the major vendors are supported by Terraform, and then you can actually use source code mechanisms, for example, branching and merging, to actually do change management. So for example, if somebody wanted to enable a certain firewall rule, they can create a feature branch, make the changes that they need to, and then create a pull request with an approval process, which can then be reviewed by the respective teams, and then that can then be merged back into the main branch, which can automatically be applied by a Terraform workspace or can be applied manually if a specific change window is needed. And then the last lesson that I would like to share is how we can shift security to the left. So by using modules with approved configurations, we can actually start improving the security posture early on in the development lifecycle, as opposed to doing security as an afterthought. One of the other things that can be done is to create an image pipeline with known good configurations and security agents as needed in order to do that. And the sooner we can get such capabilities into the development lifecycle, the better our security posture would be. Terraform also supports policy as code. So if you're using Terraform Cloud or Enterprise, you can use Sentinel to enforce module usage and cost optimization in the organization. Sentinel allows for fine-grained permissions and condition-based policies, and these policies can be versioned and controlled through source control as well. You can also look at using HashiCorp Vault, which is a secrets management tool. So applications that need to create credentials to access certain services or infrastructure, and this needs to be secured, something which HashiCorp Vault can do. Some of the common use cases for it include PKI for certificate issuance, as well as tokenization of data. In closing, some of the lessons that we've spoken about is the cloud operating model, infrastructure as code, componentization and scaled learning, where you build reusable modules in your organization, how you can enable self-service in your organization, as well as thinking about how you can move security left. And that is the end of my presentation. Thank you very much.